Hello everyone and welcome to today's webinar for General Contractors, How to Reduce Time to Construction. It's schedule, schedule, schedule. Today's webinar will be hosted by Henry Lederman, and he'll be taking us through the content, which will be followed by a short Q&A. As always, we're happy to speak with your team after the webinar if you have specific questions, so please feel free to reach out to us. With that, Henry, please walk us through the webinar.
Thank you, Aaron, for that introduction. And we appreciate everybody's time on the GC webinar. So the agenda for today, we'll talk a little bit about who we are, what we do. We'll describe the benefits to you, the general contractor. We'll accentuate that in the demo so you can appreciate how we arrive at these benefits. We'll talk about a new delivery system. We'll take some questions. We will give you some options for using Qnect, and we will have an ask of you. So let's get started. So who are we? We're founded in 2014 by Jeff Sharp, our CEO on the left, myself in the middle, Jeff Hauster on the right, who's the IT specialist with a Fortune 500 background. I've been detailing for 47 years, did the World Trade Center Memorial Museum in several 60-story buildings, along with a slew of many projects. As you can well imagine, Jeff and Jeff have built many companies in their career. So what do? We integrate connection engineering and detailing extremely fast. And that's really the key, extremely fast, which is where it matters and will matter to you in the delivery of your projects. And we do that while lowering costs. So what are the benefits? Primarily, importantly, we prevent schedule drift. We get steel on the site earlier. It's all about schedule. I think everyone on this call would appreciate that those are important things, especially that the probably number one pervasive issue in our industry is schedule drift due to the burden of changes, RFIs, design bulletins, conflicts, coordination. To show you how, and we'll start by bringing you to our website where you'll see that we'll set up a job, the demo job. And here, really, we have all of the general, very flexible preferences that one would need to develop the job standards, to engineer the connections, and to put them back into the model on any project. So minimum job requirements, etc. This gets filled out early, and once that's done, these parameters define the design of the joints for the life of the project. So let me take you to a project. Once you set up on Tekla, this is working with a Tekla platform, you'll download our apps. You will see you'll start with a stick model. There's nothing in it. And we will select a joint, a floor, a sequence, the whole building, and we'll send it up to the website. We've already done this. We would, just to show you, we'll call it GC-1. We would submit, and I'll just show you how what that would look like. We would submit, and Qnect is basically pulling out the data from the model, the profiles, the geometry, elevation, skews, any forces in the model, takes it up to the website, organizes it by beam to beam, beam to column flange, beam to column web, and returns it back down into the model, fully detailed, fully engineered. So let's return one that we did previously to for time reasons. Here we go. We'll submit. And now the connections are being pulled back down into the model. This is a 50-ton model, and you will see that it really doesn't matter whether it's 50 tons or 100,000 tons. Qnect is able to engineer and detail back into the model within the same day, so in minutes, hours, the same day, no matter that size. We design every connection as a custom connection. That's what makes it so efficient. And we also detailing it, which dramatically reduces the steel detailing time on the project. And so this is completed. As you can see, the connections are in, double angle, shear plate. Here we have a moment connection, full pen weld. We also do top and bottom moment plates. You can see stabilizer plates with top and bottom stabilizers or without. Here's one with stabilizer plate and connections to embed with plate washers. So suffice to say for your purposes that the connections are done for about 60 to 80% on this 50-ton project, about 82%. It's fully engineered, and it only took about a minute and a half to do. A job this size would save the detailer about 4 days of time. So that in and of itself is pretty extraordinary, and we'll talk a little bit about that. But first, I just want to show you that at every single joint, all of the engineering is there, the size of bolt, the angle size, etc. And then if we go into the code, we'll see the full text, AISE, all of the limit states, and the full engineering that goes with it. We have been validated by many, many engineer of record and connection engineers. So our engineering is fully complete and accurate without a question about that. All right, so that's the process. It's always the same. Button 1, button 2, 60 to 80% of the connections fully engineered and detailed back into the model. So let's talk about that, because we could stop the webinar right here because it defines the critical aspect of our delivery in terms of schedule. As a matter of context, we did a 4,300-ton project where we engineered and connected about 65% of the building in 35 minutes. We saved about 6 weeks of time, net time saved, which was about 48 man-weeks reduction of detailing time alone. There are other ways we reduce the time, but from a detailing standpoint, this context is important. We're working on 3 60-story buildings in New York City. We did 15,000 joints, engineered and connected in 2.5 hours. 10 weeks saved, which was about 100 man-weeks reduction of detailing time alone. And this 50-ton job, 82% engineered and connected, 1.5 man-weeks reduction of detailing time. So it doesn't matter the size of the project, whether it's 50 tons or 80 tons, and we are working on a project that size currently. The model will be engineered and connected for about 65 to 60 to 80%, and it will be done so within 24 hours of the model being completed. So imagine your job and what that would mean to delivery of your steel. Excuse me. To have so much done on day one. This is also possible in the estimating stage, where we work with general contractors to provide VE items to support their bid to fabricators. And we do that to support general fabricators as well. So there are many places to avail yourself of the service, but ultimately the speed and the power of this software produce extraordinary opportunities on preventing scheduled drift. But we don't stop there. Let me now show you another way that we prevent scheduled drift, which has to do with revisions. As we all know, the jobs fall apart. They fall apart under the burden of RFIs, design changes, coordination, late coordination, clashes of different trades. And so while we create this extraordinary amount of buffer time on the front end, we also contain schedule drift by the speed of revision. So let's do a revision, and we'll go here. We'll say like we change the beam size to a 4331. We apply, we say okay. The minute we hit modify, our engineering tool comes up. We will re-engineer for this change. You will notice that all the connections were pulled, and we'll call this GC, let's say RFI-1, because that's tracked. We will submit it up to the website. And instead of hitting button 2 with revisions, it just comes back down automatically. So we're waiting for this to complete. Again, there are about 12, maybe around 12 connections, and it took about 20 seconds. And fully engineered. And when you think about how the speed matters here, is to also understand the conventional methodology where the GC hires a fabricator, fabricator hires a connection engineer and a detailer. The connection engineer produces the standards, gives it to the detailer. Detailer has to interpret, puts it in the model. Then they have to check that it was interpreted right, put it back in the model, and it's quite a process. We integrate those two things in one step, extraordinarily fast. We also carry the full connection engineering package, excuse me, or contract, where our connection engineering partner will stamp our work, finish the standards that we didn't do in the conventional way, and stamp those, deliver a full package. So these two elements are the way we are able to produce so much time savings and prevent schedule drift. And now I'd like to show you how we lower cost. And we're going to do that by activating our optimization tool. So to do that, we simply do bolt optimization. And now we'll go back to the model. And as you can see, there are 6 bolts here. And what we're going to do is we're going to re-engineer this joint with the same loads. We're going to delete it. And we're going to select the beams, hit button 1. We're going to do GC BUP-1, submit. And Qnect is right now engineering this connection and creating the component for the detailing aspect. And let's see, it should be ready already. And it is. So let's bring that back down. And we see that it, in fact, has, as expected, engineered the joint with fewer bolts. So we see we have 6 fewer bolts to buy. We have 2 fewer bolts to install in the shop, 4 fewer bolts to install in the field, and total of 12 fewer holes to drill, cut, or punch. And if you add that up for hundreds and thousands of joints, it really is consequential. As a quick measure, we typically save 1 to 1.5 bolts per ton in a project. For example, we're doing an 18,000 ton project in Boston, and we're saving 22,000 bolts. That means 22,000 fewer bolts to erect, install in the field, which again reduces time to erect, but it also means 44,000 fewer holes to cut, drill, or burn in the shop. And again, that means less time in the fabrication. And of course, we've just saved the purchase of 22,000 bolts. So that is our optimization feature of lowering cost while simultaneously adding to the time buffer, prevention of schedule drift, reduction of time to erection. So that's optimization. All right, so now let's talk about a new delivery system, delivering a fully connected model. And, a good way to start this is the quote from Tishman's senior VP in New York, Allan Paull. He says here, when we convinced the owner to allow us to prepare a connected model prior to bid, we picked up 3 to 4 months. What is a connected model? A connected model is a stick model, as we saw at the beginning, that has all of the connections in it, and only the connections for all the main steel, fully engineered, approved, turned over to the fabricator. It can be utilized during the bidding stage or transferred after. Qnect is the infrastructure for this kind of delivery. We're being used, for example, on a 60-story in New York City. They're up to the 40th floor, and the job is only currently, or hasn't even been bid yet. So if you think about it, if you have a project and you start the detailing 4, 6, 8 weeks prior to the bid, and the bid takes another 8 weeks, you're already 16 weeks ahead of the time. When you add the speed of Qnect, it starts to be truly meaningful. AISC is certainly a big proponent of us, and he understands and talks about that we are part of the delivery of their initiative to reduce steel to erection by 50% by 2025. So that's a fully connected model, and the benefits of a fully connected model is dramatic time savings. You will find that the bids are more uniform. They tend to be more efficient. Obviously lowered costs due to the optimization. And in the reflection on a project or two, GC has reported that because so much is done so early and a lot of the issues are teased out prior to the fabricator and many other bidders, observation of reduction in extras from 30% to 10%. So now we'd like to open up the board for questions. And Christian, if you can send me whatever questions you have coming in. Okay. Okay, thank you. I see a first question is, do we comply with OSHA? Excuse me. The answer, of course. Everything that you would expect that's required in the putting together of a building historically and currently, we conform with in a very flexible way. Okay, let's see. Next, do you cover full connection engineering? The answer is, of course, we do. As I said before, we will take the contract. Our connection engineering partner will stamp our work and finish the rest of the job. What jobs? What jobs have you done? It runs the gamut. 60-story buildings, New York City, Seattle Airport, Kansas City Airport. We've done data centers, Disney projects. You can well imagine throughout the United States. Thank you for that question. Okay, thanks. I see another question. What GCs have you worked with, directly or indirectly? Thank you for that question. So we've worked with Tishman, Whiting Turner. We've got a job going with McCarthy. We're being used on 2 projects with Clark, Jacobs, Suffolk, and many more. So yeah, we've got quite a few opportunities. So what are the options for using Qnect in delivery of a steel building? Well, first, you can bring Qnect to your bidders and ask them to work with us. That's the simplest. You can also scope Qnect as a requirement for bidders, and they will contact us, and we will build a model and support their unique preferences and help them with VE items. You can ask bidders to provide a credit deduct for time and cost savings based on Qnect. Again, They will contact us, those who are interested, and we will work with them. And you can also deliver a fully connected model. Our ask of you, we would like you to add us. We would like you to add us to your bidding list. And that way we can, once we receive a bid, we will reach out to you to learn of the fabricators who are bidding it, keep that confidential, and bring the value to them. Unless you're delivering a connected model, of course, then we'll be earlier on, or it's a design assist, which we can play a huge part in. And the second thing is we would like you to select an upcoming job and provide us with the design drawings and Revit or IFC file if available. We will build the model, provide you with VE data, so you can see the impact of a software on a job that matters to you. That is always consequential in terms of really appreciating the opportunity. So we'd love for that to happen, those two things, and we will reach out to you, and we hope you will reach out to us in the coming days. So let me close and thank you for making time today. You can contact Qnect, Christian, and any one of us here, and we look forward to working with you. So thank you.